So hello learners, once again I welcome on the class of Foundation Engineering. So I hope you all are safe and doing well. So in the previous discussion, I have discussed about the types of foundation according to the Terzaghi, and after that I have discussed the general requirements of foundation, and after the general requirements of foundation, I have discussed about the how to compute the bearing capacity method, bearing capacity. So there are three methods to compute the bearing capacity: analytical method, building codes, and in situ test. And in situ test, I have discussed there are three types of test. One is standard penetration test, second one is cone penetration test, and this cone penetration test is further divided into two types: static cone penetration test and dynamic cone penetration test, and the third one is plate load test. And after that I have defined the some terminology which is very important for the foundation engineering, like what is gross what is net ultimate bearing capacity, what is ultimate bearing capacity, what is net safe bearing capacity, and what is safe bearing capacity. And after that I have uh, uh, I have discussed about the how to compute the depth of foundation by Rankine formula. So according to the Rankine, the depth of foundation can be computed as Q by gamma 1 minus sin phi divided by 1 plus sin phi whole square. So today I will discuss about the the first one, analytical method. And in analytical method, firstly I will discuss there are three modes of failure in the analytical method, like general shear failure, local shear failure, and punching shear failure. So what is general shear failure, what is local shear failure, and what is punching shear failure, I will discuss one by one in details. And after that I will discuss the uh, Terzaghi equation or Terzaghi's method to compute the bearing capacity of the soil, and with their various assumptions. So firstly I will discuss about the analytical method. There are three modes of shear failure based on their shear failure pattern. So there are three modes of shear failure based on their shear failure pattern. And what are these three modes of shear failure? So the three modes are: the first one is general shear failure, and the second one is local shear failure, and the third one is punching shear failure. So these are the three modes of shear failure. The first one is general shear failure, second one is local shear failure, and third one is punching shear failure. So the firstly I will discuss about the what is general shear failure. So if I talk about the general shear failure, so the general shear failure occurs in dense sand and OC material, means over consolidated material. I hope you must have know about the over consolidated material. And in general shear failure, the shear failure occurs in such a way that there is a heaving of soil mass, and this type of shear failure occurs when as I told you that general shear failure occurs in dense sand, so the relative density is greater than 70% and angle of internal friction is greater than 36 degree. Similarly, failure is accomplished by the tilting of the footing, and there is a sudden failure That's why stress strain curve of or load settlement curve of this is uh, uh, this type of shear failure is in the brittle in nature, and it has well defined failure surface. So if I write these things, so the first things I have taken, this type of failure occurs in dense sand and OC material. OC means over consolidated. Soil has relative density ID greater than 70% and angle of internal friction is 36 degree. So these are the data where we can identify with the help of this data we can identify the types of failure. Third point is it has well defined failure surface and failure surface touches the ground surface. Fourth point is bulging of ground surface failure is occur when tilting of footing and sudden failure and load versus settlement curve will be of brittle type. So these are the points I have discussed. This type of failure occurs in dense sand and OC material. Soil has relative density greater than 70% and angle of internal friction 36 degree greater than 36 degree. It has well defined failure surface and failure surface touches the ground surface. Similarly, bulging of the ground surface will be occur and failure is occur when tilting of footing and sudden failure होगा and the load versus settlement curve will be brittle type. So if I draw the so this is the footing, this is load acting, this is our ground surface, this is passive zone, and this is the log spiral nature. Failure surface will touches the ground surface. This is passive compression zone, and this is the failure and I told you there is a bulging or heaving of the soil. So this is the bulging of soil is bulging or heaving, and this is log spiral in nature. This is also failure pattern. So this is our foundation. So this is the failure surface. So what I told about the general shear failure. So this is our general shear failure. In general shear failure, I told you this type of failure occurs in dense sand and OC material. And the second thing, when there is the type of soil is dense sand, means relative density is greater than 70% and angle of internal friction is greater than 36 degree. Third point, I told you that it is a well-defined failure surface. You can see that we can easily see the failure surface, and this is a well-defined failure surface, and failure surface touches the ground surface. Yes, failure surface touches the ground surface, and there is a bulging of at the ground surface. Bulging or heaving will be at the ground surface. And the third next thing I told you that this type of failures occur uh, and there is a sudden failure. So sudden failure will occur, and load settlement curve if I draw. So this is the load settlement curve, and load settlement curve, load settlement. So the load settlement curve will be look like this. So this is load settlement curve, and it will be brittle type. So this is the load settlement curve for the general shear failure. So the second type of shear failure I am going to start, that is local shear failure. Local shear failure. So local shear failure, local shear failure occurs in loose sand. Relative density or density index, relative density lies between 30 to 70%, and angle of internal friction phi is less than equal to 29 degree. That is, ID lies between 30 to 70%, and phi is less than equal to 29 degree. So the first property of the local shear failure is local shear failure occurs in loose sand, and relative density lies between 30 to 70%, and angle of internal friction less than equal to 29 degree. Third property is failure pattern. Failure pattern is well defined only below the footing. Failure surface will not touch the ground surface. Slight bulging occurs at the ground surface. No tilting of footing will occur. Larger settlement of footing and bearing capacity is not well defined. So these are the properties of the local shear failure. The first one is local shear failure occurs in loose sand and relative density lies between 30 to 70% and angle of internal friction less than equal to 29 degree. Third point I have discussed, that is failure pattern is well defined only below the footing. But we have seen in general shear failure, failure pattern is well defined entire the footing and failure surface easily touches the ground surface, but in local shear failure, failure surface will not touch the ground surface. There is a bulging near the footing in general shear failure, but slight bulging will occur at the near the footing, and there will be tilting in the tilting of footing in the general shear failure, but there is no tilting of the footing. Larger settlement will occur in the local shear failure. In general shear failure, bearing capacity is well defined, but in local shear failure, bearing capacity is not well defined. So if I draw the pattern, so this is our footing, this is load P, similarly here is also, this is the ground surface, and slight bulging you will get at the near the footing. Slight bulging will occur. So this is the local shear failure. And if I discuss about the load settlement curve, so this is load settlement. So this is the load settlement curve for the local shear failure. Third type of shear failure is punching shear failure. Punching shear failure. This type of failure occurs in very loose sand. The value of relative density is less than 30%. That is, ID is less than 30%. Failure pattern is not well defined. No, sorry, no bulging near the footing. No tilting of footing, and the bearing capacity is not bearing capacity is not well bearing capacity is not defined. If I draw the pattern, so this is the footing, so nothing will happen, no failure pattern, nothing will happen in punching shear failure. And if I talk about the load settlement curve, so this is the load settlement, so this is the load settlement curve for punching shear failure. So this is all about the general shear failure, local shear failure, and punching shear failure. So dear student, today I have discussed about the analytical method, and in analytical method I have discussed the three modes of failure due to the shear failure pattern. And these three modes of failure were, the first one was general shear failure, and the second one is local shear failure and punching shear failure. So about the general shear failure, I told you that this type of failure occurs in dense sand and OC material, means over consolidated material, and the relative density is greater than 70% and phi is greater than 70%, and angle of internal friction is greater than 36 degree. It has well defined failure surface, and the failure surface easily touches the ground surface, and there is a bulging occurs near the footing. And this type of failure occurs when there is a tilting of footing will occur, and there is a no settlement of the footing, but and the bearing capacity is well defined in general shear failure, and the load settlement curve is of the brittle type of nature. In local shear failure, I told you that this type of failure occurs in loose sand, and when our relative density lies between 30 to 70% and angle of internal friction less than equal to 29 degree. It has well defined surface but only below the footing, and the failure surface will not touch the ground surface, and there is a slight bulging at the near the footing will occur. There is a no tilting of footing will occur in loose sand, but there is a huge settlement of the footing, and bearing capacity is not well defined in the local shear failure. The third types of failure I have discussed, that is punching shear failure. So punching shear failure will occur in very loose sand, means the relative density is less than 30%. It has no well defined failure surface, and failure surface will not touch the ground surface. There is no bulging or heaving at the ground surface or near the footing, and there is a huge settlement of the footing, but there is a no tilting of the footing, and bearing capacity is not well defined in the punching shear failure. So in the next class I will discuss about the Terzaghi method to compute the ultimate bearing capacity with various assumptions taken by the Terzaghi, and we will see the expression of bearing capacity and for the strip footing, and after that I will derive the bearing capacity equation for the rectangular footing, circular footing, and a square footing. And after that, I will discuss the what is bearing capacity factor like NC, NQ, N gamma, and on which factor this bearing capacity factor will depend. So take care of your health and happy learning.